Good afternoon. This is your next lesson in the series Maths Revision Outside the Classroom. Today's lesson is on scatter diagrams. This is level 6 at Key Stage 3 or grade D at GCSE and is suitable for years 8 through to 11. So why do we use a scatter diagram? A scatter diagram enables us to spot relationship between two sets of data. We have two sets of data in front of us. We look to see the range of each set of data, and hence we draw our x and y axis. The first line of data, be it on the top or on the left hand side, we usually plot on the x-axis, and the second line, the one on the bottom or on the right hand side, we plot on the y-axis. Should the data be very spread out, it's a good idea to have an axis that ranges from 0 up to 100, say. But should the data be all in one region of the graph, such as all the data in the 60s and 70s, we wouldn't start our scale at 0. We would use an axis break, which is a little zigzag line drawn next to the 0, and we would start our scale at, say, 50. And hence rise up to about 80, so that our data is not all grouped in one particular part of the graph, which would then disguise any relationship that exists. So having drawn out suitable axes, we then plot the points. Each of the top numbers is plotted against its corresponding partner on the bottom, or each of the left-hand numbers with its corresponding number on the right. When we've plotted our points on the graph, we then examine the graph and see if we can see any connection between the points. Do they lie in a straight line? If the points lie in a straight line with a positive gradient, that means the line goes uphill from left to right, we call this positive correlation. If the points are very close to the straight line, it's good positive correlation. If they're not very close, it's weak positive correlation. If there is positive correlation, we can say that as the x variable increases, the y variable also increases. And that is our relationship. If a relationship like this exists, we can draw in a line of best fit. This is drawn with a ruler. It's a straight line that's drawn such that the points are roughly equal on either side of the line. So the line will not join the points, but it'll pass through several of the points, and the remaining points will be equally scattered on either side. The line is drawn so that the distances between the points are as small as possible. When we have drawn our line of best fit, as it's called, we can then use it to predict missing values. Say we have a missing x value, we would go up to the corresponding y, do a dotted line across to the graph, to the line of best fit, dotted line down to the x-axis, and read off the missing value. Should we have a missing y value, we go along to the corresponding x value, dotted line up to the line of best fit, dotted line across, read off the corresponding y value. If the points are very close to the straight line, this should be a reliable estimate. If the points are close to a line with negative gradient, we would call this negative correlation. And we would say that our relationship is such that as the x variable increases, the y variable decreases. An example of this might be, as sunshine hours increase, umbrella sales decrease. Whereas an example of positive correlation would be, as rainfall increases, the sale of Wellington boots also increases. If we have negative correlation, we can similarly draw a line of best fit, providing the points lie reasonably close to a straight line. If they're very close, it's strong negative correlation. If they're not particularly close, it's weak negative correlation. If the correlation is reasonable, we draw our line of best fit and may use it to make estimates like before. If, however, the points are randomly scattered all over the graph, we say there is no correlation and no relationship between the variables. In this condition, there is no point in drawing our line of best fit, and we cannot make any reliable estimates from our graph. Should we wish to make an improvement in our line of best fit, we can make its accuracy better by plotting the mean of the x numbers against the mean of the y numbers and drawing our line of best fit through that point. This point is called the mean point and may help to position the line of best fit accurately for making predictions. Well, that is it for this particular lesson on mathematics revision outside the classroom. We hope you found it useful